Hello. This is going to be a quick and dirty sort of tutorial walkthrough on how to set up and take a simple free mocap recording. We're going to be using kind of a janky-ish workflow using sort of the current iteration of the software. So a lot of the sort of the basic like how to use the software stuff is going to change. But we're also going to cover a lot of really basic concepts in motion capture and camera-based stuff. And those concepts won't change. Those have been the same for as long as we've been doing camera-based motion capture. So this is going to be kind of, quick and dirty, like a living document. We're sort of trying to use it as a starting point to build better documentation, but we want to just get as much of this information online as we can so that people can work from it as we make cleaner docs. We're going to be using, so it is currently October 28th, 2022. If you're watching this significantly after that, all these software might be stuff might be out of date. We're currently using the last main official release is version 0.0.54, which is what we call the pre-alpha, and we're also going to be using what we've been calling the alpha GUI before 0.1.0. Instructions on how to get that stuff up are on the GitHub. This is Pooh. I am pandering. So the workflow is going to, kind of janky workflow, is going to be using a combination of the pre-alpha and the alpha, mostly because the alpha GUI does not currently handle, like, the camera, the way it handles cameras is kind of suboptimal, so we're going to be using the pre-alpha to record the synchronized videos, and then we'll be loading them into the alpha to process them. So if you go to the GitHub, which is github.com/freemocap/freemocap, you can also go to the website and click Get Free Mocap. It will take you there. Scroll down, and here's how the installation, the basic installation stuff tells you how to install the pre-alpha. So just gonna do that real quick here. Conda create -n freemocap -n python equals 3.7. Punch it. Yes. And then yes. Oh, this is using an Anaconda prompt. So if you go to anaconda.org, install that, and then search for Anaconda prompt and open it up, it will help you set up your Python environment. Details forthcoming. Okay, I created the environment. Conda activate freemocap -env, the thing I just made, and then see how that thing on the left just changed to say freemocap -m. That means we are currently activated in that Python environment. Details forthcoming. Okay, and now I'm going to install freemocap, pip install freemocap, and I'm going to specifically pin it to the pre-alpha version equals 0.0.54. Punch it. Oh, and then I'm going to have to upgrade MediaPipe as well because I got to do that. These are all the packages that are installed. We might wind up just zooming past this in the recording, or we might not. Doesn't matter. Yeah, so freemocap uses a bunch of different environments, a bunch of different packages. NumPy always, OpenCV is how we interact with the cameras, AnyPose is how we do the calibration, MediaPipe is how we do the skeleton tracking, and we have to now upgrade pip install MediaPipe pipe --upgrade, because the version that gets installed automatically actually has an error with it. It's red, but I think it's probably fine. Conda, actually let's do pip list. You can see all the things that have been installed here, and specifically checking that MediaPipe is 0.8.11 and freemocap is 0.0.54. Hooray! So that is the pre-alpha stuff. I'm also going to make another environment to run the alpha GUI. This is the janky part. There are also instructions on so if you want to, on the GitHub in the README, scroll down to where it says how to run the alpha GUI. So I'm going to deactivate the freemocap env and say conda deactivate, and see it goes back to saying base there. Enter, just to give me space because it feels comfortable. Color equals 3 because it's cool that you can do that. Conda create -n freemocap -GUI Python equals 3.9. So that's making another environment using Python 3.9. That's the one that we're going to use for the alpha GUI stuff. If this doesn't make sense to you, I understand. Conda activate freemocap GUI. This is the stuff that we'll get it. We'll clean this up. Okay. So now so the new version is not on PyPy yet, so you can't just pip install it. So we're going to do git clone https://github hub github.com/freemocap/freemocap, and that's cloning the repo onto your computer using Git, which also needs to be installed, and which is roughly the same thing as just downloading all of these files onto your computer. What did I say next? Oh yeah, so then I have to cd change directory into the FreeMocap folder that I just cloned, and pip install -r requirements.txt, and that's going to install the requirements that are listed in the requirements.txt file in the repository, which is, where is it? All these guys, which is more than we need, but don't worry about it. We'll clean it up. I'm just going to keep saying that. Someday it will be true. Look at all these. It's way too much. It's fine. It's fine. And yep, you can do it, buddy. I think so. That should work. I realize I'm also going to have to switch over to like a different branch of GitHub to run the GUI, but that will be fine. I think we'll do that later in the video. Okay. So look at all this fun stuff. It is all installed. Hooray for us. And now to run the GUI, we're going to run this main.py file, which lives in a folder called source src /GUI/main/main.py. We're going to see if this works. I think it will. Python. So we're running that with Python. So basically it's pointing the version of Python that lives in freemocap-GUI towards that particular Python script. /GUI/main/main.py. Huh? Bunch of stuff. Hey, there you go. Okay, so we could record from this, but I don't trust it enough because the camera stuff is janky. We'll talk a little bit about that later. But this is just proof of concept that it did in fact work, which I didn't do. Oh, it lost its pretty color. I'm going to also check on the pre-alpha right now. Conda deactivate, back to base. Conda activate. Let's pretend I forgot what environments I had. Conda info-e. Oh look, there's actually a bunch, but one of them is freemocap-n. Activate freemocap-env. There we are. And now we're testing the pre-alpha, just making sure it worked. I'm going to start an IPython session, I guess. Notice that it is using the right version of Python because I'm using that environment, 3.7 instead of 3.9, which is the one I did for the GUI. It's fine. Import freemocap. Hey, freemocap version version dot 0.54. Hooray, we've done it. Okay, freemocap run me. Hey, look at all that good stuff. It found one camera. Hooray for us. Control C? No. Yeah, okay. Okay, so we've got our software installed. So the actual workflow we're going to use is, we're going to use the pre-alpha to record synchronized videos that we're going to process with the alpha. And we're going to need to, so we're going to record calibration videos independently, at which point I will talk about calibration in cameras and pointing to your cameras and yada yada. Record those videos for the calibration stuff. And then assuming the cameras don't move, we don't need to recalibrate after that. And then so we'll record the calibration, and then we will record videos of the actual motion capture, which is going to be my brother doing some dancey, musicy stuff. And then that should be that. So before we actually take any recordings, let's talk a little bit about the hardware that's going to be necessary to get a good FreeMocap recording, or any FreeMocap recording. First of all, by far the most commonly asked question is, what kind of camera do I need to use? The answer is it should work we've been trying to make it work for any sort of cheapo USB camera. It's a big part of the vibe of this project is we've been specifically targeting like the cheapest, most garbage, beautiful cameras you can get. This one is a model that I sort of started to identify and get. It looks roughly like this, and you can see it, like if you look at it for like, on a place that you would buy electronics, it often has this little garbage tripod with it, which is not a good tripod, but the fact that it's in the picture tells you that there is a port on the bottom that has a screw port where you can put it into a tripod, which is really helpful. In general, and to make your life a little bit easier later, mark just some kind of mark on the camera, also on the port. It will make life easier later. So for this recording, we're going to be using 3 cameras, choosing 3 because this laptop has 3 USB ports, which means I can plug 3 cameras straight into the computer. Another very, very common question is, can I use a USB hub to sort of, run like 4 cameras through a single USB port? We really don't recommend doing that. It can work sometimes, it's just a little intermittent. The problem is at that point, you're funneling a lot of camera data through a single USB port. So eventually you'll start getting like frame rate issues. If you don't have enough USB ports available on your computer, get a hub and move all of your peripherals to the hub, like your keyboard, your laptop, and keyboard, mouse, all that kind of stuff. Put that in the hub and try to put your cameras straight into the back of your computer if possible. If you must use a hub, just minimize the number of cameras that you're putting through it. So if I had 3 cameras and only 2 ports available, I would put 1 camera straight into the computer and then the other 2 cameras into the hub. And then just check the frame rates after the recording to see if you can get a good recording. We'll talk about how to do how to look at the timestamp diagnostics to see if you're getting a good recording later on. Yeah, you're also going to need, so necessary equipment, cameras, roughly speaking. What I have found, if the cameras I'm buying are about $20, they work. If sometimes I'll see like, oh, there's some $10, $8 cameras. They don't work. I don't know why, but $20, the goal was make this work, the cheapest possible motion capture equipment with the cheapest possible cameras. It appears that floor is about $20. I don't know why. If you do, please tell me. But optional equipment, tripods. It will make your life easier because you can point the cameras. You could just put them on tables and chairs and stuff like that. It doesn't matter, but tripods will make your life easier. Also will make your life easier, USB extension cables. Ideally with the blue tab, so they're USB 3. Shouldn't matter because these cameras are USB 2, but I have had better luck with the USB 3. So similarly, mark both ends of the cable. It will make your life easier. This one was like is like a 6-foot cable. This one's longer. You can usually get them in like packs of 4, which is, cost effective. And so, yeah, so we're talking about the basic workflow, the sort of simple, the easiest possible methodology here, which is USB cameras attached directly to your computer. However, you can use whatever cameras you want as long as you synchronize them sort of on your own. And for synchronization, like frame perfect synchronization, meaning if you record from like 4 different GoPros, you have to synchronize them somehow. And then in the end, you have 4 GoPros videos. Each of those videos has precisely the same number of frames, like exactly the same number of frames, and those frames are synchronized with each other. So frame 12 of video 2 is the same instant in time as frame 12 of video 3. And I'll show you later how to import those synchronized videos into the Alpha GUI. But if you want to just have like a one-click sort of iterable time sort of workflow there, the USB wired option is the simplest one because you don't have to sort of synchronize them on your own. First thing we need to do is sort of set up our physical cameras to roughly point at the place that we're going to be recording from. Some relevant sort of terminology here is we're going to point the cameras so that their fields of view, which is just the area that the cameras can see, are overlapping in a certain area. And that overlapping region of the camera's fields of view is going to define what's called the capture volume, where the capture volume is the 3-dimensional space in the area in the room that you can record and get a good sort of recording of someone. So I'm working in a limited space here, so I haven't actually looked at through the views of these cameras yet, but it's going to be roughly here is going to be our sort of main capture volume, kind of this-ish area. And so I've set up the cameras in this kind of like amphitheater setup where they're kind of in a semicircle, all facing at me. If I had more room, I would do a circle, but I don't. And we want them to be sort of far enough away that they'll be able to capture the entire body of the subject when they're being recorded. There's no reason why we couldn't do like a half body thing. It's just the software doesn't really handle incomplete bodies very well at the moment. So in a little bit, we're going to look through the viewport of the camera to sort of do some real orientation and change some settings. But for now, I just, each camera has been attached to a USB extension cable plugged directly into a USB port on the laptop. The laptop is plugged in. And also you'll notice I have covered the mirror, which is an important thing to do. And probably between this and the next shot, I'm going to set up this sort of white backdrop behind the camera. It's not strictly speaking necessary, but it will probably lead to better tracking because it's just cuts away some of the visual complexity. It's just easier to track a hand if it's got a white background on it versus if it's got like a bunch of sort of complicated visual texture behind it. Quick sort of like workflow thing. When I first was planning this out, my intention was to have the capture volume be here and have the camera set up like that. So I originally had this camera there, and then this camera there. But then I realized that it actually wasn't as much distance as I might need. So I shifted everything. It's like a human brain thing. In my brain, I'm like, oh, the room is oriented like this. But geometrically, if you just think about putting the person here, you can have longer distances between yourself and the camera and sort of get a better sort of nice overlapping capture volume. It's always, a lot of this is about trade-offs, right? Because on the one hand, the closer the camera is to the person, the more of the field of view the person is taking up, so the more information you're capturing, so the better your capture volume will be. However, as you sort of get too close, all of a sudden, like, you can't move your hands all the way out because that camera will not be able to see your hands. So you want to be farther away so you can capture more of the person. And so the right distance, the right location really is dependent on the space you're recording in and the activity that you're going to be recording. And so for us, I think that since it's going to be kind of a constrained thing, we're going to talk about the actions we're going to mocap later. This feels like an okay setup. Okay, so now that I have the cameras kind of like roughly the right location, now I'm going to open up the software and orient them more specifically based on what I can see through the cameras and change some of the settings to be better for our recording. I can't remember if we said this last time, but I think we're gonna record the calibration videos through the alpha GUI because the frame rate doesn't matter for the calibration part, and then we'll record the actual mocap videos to the pre-alpha because the frame rate matters a lot. That will also let me show you how it looks to like import videos from another source. So we are back on the computer. We set up the environments previously. Let's pretend I forgot what they were called. So conda info-e, and I say, oh yeah, look, it was free mocap GUI. So I'm going to say conda activate free mocap dash GUI. See, a thing from base changes to free mocap GUI, and then it was, oh, where was I? After this, like CD, I think of 2022. I forgot the folder I actually cloned it to. It's this folder, and then I can CD into free mocap. Haha. And then it was Python source /GUI/main/main.py. The instructions are on the GitHub repo. I just forgot about them. And I think if I run that, how do you feel about that? How do you feel about that, buddy? There you go. Good job. Okay. So here's the old GUI. Here's the new GUI. And let's see. We're going to say create new session. So clickety doodle there. Name it that. I'm going to give it that's the auto-generated session ID. Oh, which is actually not what it should be. I'll fix that later. It should be year, month, day, hour, minute, second of creation, but the date is in the wrong order. I'll fix that later. Duration. I'm going to add that tag. Start session, and then I think, oh yeah, there's no output to the GUI of like its status, so I want to keep the terminal open. Okay, camera 3 appears to be the laptop camera, so I'm going to go down here and uncheck that, and then I'm going to, let's see, anything else I'm going to do first? No, I'll just let that apply settings and launch cameras. There's no reason why I couldn't use the laptop camera for this. I don't understand it as much, so I'm not going to. And here we go. It's doing that weird thing. Is this going to work, or am I going to have to? Okay. That I'm checking that I wave my hands to see if it's actually tracking at a reasonable frame rate, and it kind of is. I think it'll be fine for calibration. Okay. So this camera is close to right. It's also oriented vertically. I'll change that in a second. So I'm going to sort of, roughly speaking, point it at my brother, who's also dutifully filming, and that's good enough. I actually want to get that closer. Yeah, go stand like right there. Because again, we really want him to be sort of taking up as much of the space as we can get. Like, we want to utilize you want to use the pixels of the cameras efficiently, which means that we don't want to waste them with sort of background and stuff like that. Okay, there you go, you're okay. So actually in retrospect, that space would have been probably fine. Now this one is currently, so the default of a camera is to be in landscape mode. that humans are actually oriented portrait mode. Humans have an portrait mode aspect ratio. So I'm going to rotate it so it's like that. And then that looks pretty good. Take a half step back, Paul. Okay, and then this one is the last one. Also going to be, and you always want to, I'll do this in a second. So I'll go back where you need to be. We're actually getting, oh, it's over there. The frame rate's really bad right now, so I think I might actually wind up switching back over. Yeah, that frame rate, yeah, it's doing that jello thing, which is a sign that something's screwy under the hood. This is not a surprise, it just kind of needs to be fixed. So the cameras of the Alpha GUI were having frame rate issues, unclear why, so we're just going to switch over to the pre-alpha. We're working on changing all the back-end methods for connecting with the cameras in the GUI, so that will be a fixed problem soon enough. But for now, we'll just do this sort of, basically get the videos from elsewhere and then process them in the GUI, or via the GUI. So now we're going to switch back over to pre-alpha mode. Again, sort of following instructions that are in the GitHub repository. This is the simple stuff, and then you can click here into the old README, which has more instructions on how to use that version of the software. But we're going to, let's see, conda activate free mocap-env. There we go. Start an IPython session. There you go. It's got the right version of Python. Import free mocap. There you go. And then free mocap.run me. Don't want any of the other, he said any other parameters. I'm going to set the Charuko square size, and I'll explain that in a little bit. Charuko square size is 126, which that is the length of one of the black squares in millimeters. We'll get to that in a second. Go. So then pre-alpha, it cycles through, looks for all the cameras you can find attached. 0 through 3. If I recall correctly, 3 was the laptop camera. I think those numbers remain. I'm not sure. And I'm going to have it go into setup mode here. So submit that, and then they need to be rotated. So I remember I changed them to portrait mode, but I didn't rotate them in the image. So I have to remember which one's which. I can't, and they're different. So I'll just set them all to rotate by 90, and I'll fix it later. Also going to change the resolution to 1280 by 720, which is the default for the pre-alpha. And I'll set the exposure to -7. Again, I will explain that in a second. Frame rate and codec don't actually do anything right now, sorry. And I guess I'll turn this overlay on too, if it's helpful. Okay. So here we are. Ah, shit, that one just crashed. Okay, so one of the cameras, so camera 0 crashed, which is not ideal. I'm trying to think of why. I'm gonna I set this power to best performance on my laptop, and then I'm just gonna try it again without the MediaPipe overlay, because MediaPipe overlay is a lot to ask of the CPU, and that helped. One of those two things helped. Okay, camera 0 and camera 2 are upside down, so I'm going to press escape again, change parameters. Camera 0 from 90 to 270, camera 2 from 90 to 270, punch it again. And okay, those look pretty good. Let's see here. So I'm going to move these a little bit. Okay, it actually is getting the bottom of the screen. So this camera is going to get rotated down until it can see his feet. Okay. Oh, I'm going to be out of frame here, but that's okay. And then this camera here, there you go, so we can see his feet. He's spreading his arms to let us know how good that looks. Outside camera. And then this one might need to move actually. So I think I can move this one farther away. And okay. cool. So it's losing a little bit of his right hand there from this camera. So let's see if I can move that one a little bit. Yeah, so that looks fine. Let's see if I can point a little more light at him too. So the trick with the camera setup is, we also, so you're almost gonna get your foot blocked by the red couch. So that one actually.
That's fine, whatever. We can do this.
Okay, we can also move that. We'll probably wind up moving that couch. Not just yet. We'll do it off film. So notice that the image looks a little dark, which is a good thing. We want it to be dark because if you look at my hand, when I move it back and forth, it doesn't get super blurry. If I sort of go back and change the parameters, I'm going to change the exposure setting to say -6, which is a higher exposure setting, means the digital shutter is collecting light for a longer time. Start the images. Now it looks brighter, but if you look at my hand, it blurs more when I move it. And so you want it to get good, crisp images. Yeah, it's actually still, I wish we had spotlights, but the spotlights I have are not here, so we work with what we got. So with exposure, it's another one of these things where it's a trade-off where you want this number to be as low as you can get it. I think we're going to have to be at -7 right now. I wish it was like -8 to -9, because that means the intuition here is that the exposure of the lower the exposure, the shorter amount of time that the shutter is open. So it gets less light, but it also any movement is not going to have enough time to blur in the image. So you want to have so it's lower exposure leads to darker images, so you want really bright lights. So yeah, but in this case I am using my intuition here and saying, okay, -7 is as low as we can get with this lighting. If I had spotlights, I could probably get it down to -8 or -9, but that's fine. So now we're going to get into calibration, and calibration, we're using a Charuko board based method. Specifically, we're using the AnyPose implementation of OpenCV's Charuko based method. These are all Charuko boards. So the traditional method is to use a checkerboard, which is kind of, imagine something that looks like this, but with white spaces. This is called a Charuko board because these little markers in the white spaces are called Aruko markers. So you combine they call it chessboard, but that's a checkerboard with Arukos in the white squares is a Charuko board. I have several of the size doesn't super matter, except that the bigger it is, the farther away the cameras will be able to see it, just because they're larger in the image. I have a couple of different options here. The default values in FreeMocap assume it's printed on a 8.5 by 11 inch sheet of paper, which is roughly equivalent to like A4 paper if you're over in the other part of the world. And we are going, so this is in the classic form of calibration, this is a known object of known shape and geometry that is designed to be very easily tracked by computer vision. And we're basically sort of in an automated way under the hood going to use our knowledge that this thing is in fact a grid of sort of regular shapes to calibrate the rest of the cameras. The basic idea is that you use your system, if you're setting up a system, you want to take a measurement with it, you can use that system to measure something that you already know the answer to. And that will allow you to trust the measurements that you get over the thing that you don't know the answer to, which in our case is the human moving around. Get off this computer. Okay. So yeah, so one of the parameters you're going to need to put in for the calibration is the size, the size of the Charuko square, which size in this context refers to the length of one of the sides of one of the black squares. And this one, that's 123 millimeters. You do want to be measuring them in millimeters, although it doesn't super matter. This is 123 millimeters wide. This one is 58 millimeters. And then this sort of default standard printer paper is 39 millimeters on the side. We are planning to move to this other form of the board, which has fewer squares, which means that you can get a larger image on a standard paper. The Alpha GUI kind of works for that, but for the time being, just use the images that are on the repository in assets, I think Charuko images or something like that. We'll put a link on the video or something. So we're ready to actually calibrate the cameras. So I'm going to restart free mocap. I didn't have to, but we're just gonna, but that's what's happening. So here we are in the terminal, and I'm just gonna type mocap dot run me, and Charuko square size equals 123 or 6 or whatever it is, which again is the length of the black square of the big board in millimeters. I'm gonna hit run, and it's gonna detect the cameras, and I'm gonna select all of them but camera 3 because that's the laptop camera. I'm gonna keep it in setup mode for now. I'm gonna click submit. It remembers all the settings from last time, and go. And right, so again, it's not recording now, but I'm just double checking that we're actually tracking the board well in the current setup. And I can tell that it's tracking well because it's drawing the dots on the image. The yellow line means that they're all being detected at the same time, which is not actually necessary, but it's just a helpful image. And so for the calibration to work, it is not the case that all cameras need to see the board at the same time. But every camera needs to have like shared views with at least one other camera. So you can sort of calibrate the multiple views of the known object to sort of figure out the camera's position and rotation, and also correct for lens distortion. So now that I've seen that in the setup view, I'm going to switch over. I'm going to go over here. I'm going to press escape out of here. I'm going to change the name to add _ calibration, and then I'm going to begin recording. And the recording thing, it doesn't rotate the images and doesn't draw on the image, but that's okay. And so basically what I'm going to do now is I'm going to be kind of thinking about like painting the Charuko board over the field of view of each of the cameras. And I'm sort of like going to each one, thinking about what that camera can see, and then just kind of like painting the Charuko board so that each camera gets a nice good chunk of data where it can see the Charuko board nicely. I also tend to like to do this like rotation-y thing for it in case there's any glare in the scene. This will sort of help make sure that it's not like one camera is always seeing a super glared view. Rotating it like this is not necessary. It doesn't do anything. It's just kind of, good practice. Okay. So now I feel pretty happy. All the cameras should have enough good views of the Charuko board that they can work. So I'm just going to hit escape, and it's going to start churning through stuff. And then this image is showing a diagnostic of the timestamps that were recorded. Top left is frame number versus time, and all 3 cameras are right on top of each other. That's what you want. If the frame rates were weird, you'd see like weird jumps, and they would be like different slopes. Also frames per second, sort of histogram showing that it's getting more or less 30 frames per second with a couple of frame drops, but that's normal for cameras. So we're happy with that. So we're going to click proceed, and then it's going to start working through the AnyPose pipeline for generating the camera calibration information. That's going to be saved in a TOML file in the session folder. In the pre-alpha, I think it gets named like session ID _ calibration.toml. In the alpha version, it's going to be called just camera calibration.toml. It's the same information in both places, and the GUI has the ability to sort of like load in the calibration from another recording. So we will be able to use that. Okay, so another weird thing happened. This is an error that I don't really fully understand, but it says this async handler deleted by the wrong thread. It has something, I think it's because it's been on for a long time and we started and we stopped for a while. So it failed during the calibration part, which is stage 3, which is okay because we can just open it back up. Conda activate mocap -env IPython import free mocap, and now we're going to basically restart processing that same session from the place where it left off. Oh, sorry, it was actually at stage 2, synchronizing. It wasn't calibrating yet. Mocap.run me. I could go in and track down the session ID, but if I just leave so session ID equals, I could set that, which is the name of the folder. But I think if I leave it blank, it's set up that it will just automatically try to find the most recent one. Hopefully, we'll see. And so let's start at stage equals 2, which is the synchronization step, and then Charuko square size equals 123, and then see how that works. It did not like it, probably because I didn't specify the session ID, mocap data. Yeah, that's right, because it has this other stuff in there. Okay, So I have to grab, it's because it's for complicated reasons, but basically it didn't, I do have to specify the session ID. So I'm going to push up, and then I'm going to add session ID equals, and then in quotes, the name, oops, what the hell? Session ID equals, can I do that? No, doesn't like it. I guess I didn't have it on my clipboard. There, Control C, there, Control V, there we go. Except I need to be in quotes, quote, V, quote, go. Okay. Timestamps are still good, and proceed. And now it's going to synchronize. It's very unlikely that anything could crash in a way that can't be recovered. I've done this enough that was like one of the main things, is to make sure that if anything fails or crashes or borks out at any point in the process, you can always restart, reprocess, sort of pick things up where they left off, because that's just a part of any sort of complex data analysis, is that things are going to fail, and you have to have a plan for that. So as long as the recordings or everything else can sort of be picked up from where it left off. And so then the challenge that we're sort of currently facing with developing the software is making it more stable and sort of easier to people to use, because we don't want to have to reset it. So like the async thread was deleted by the wrong thread thing. That's a pre-alpha thing, because we weren't handling our threads as like cleanly as we should have been, but that's fine. That's life. Okay. So right now it's running through the raw videos that were recorded and synchronizing them. And we use a software-based synchronization method where we basically, as we're recording, every time we pull a frame from a camera, we pull a timestamp as well. And then after that initial recording phase, we synchronize the frames using those timestamps. It's a method that is basically similar to what the Pupil Labs people do. The Pupil Labs is an eye tracker that I've used for my research in the past. And this is basically what they do to synchronize their stuff, sort of on software side, post hoc. Okay, so the videos have been synchronized. And now we're in the capture volume calibration part. This will take a second. There's 1,800 frames, and it's just going to sort of churn through the process, the AnyPose calibration pipeline, and spit out a bunch of numbers. And I'll talk you through them as they're streaming through the screen. What is it doing now? Oh, this is actually an unnecessary step, but it's fine. It's part of the pre-alpha. Okay, so just talking over what's going on during the calibration stage. So these white bars as they're going through are running through each of the images of each of the videos and detecting the Charuco board. So you can see here, this one in the first video found 1,061 frames where some of the Charuco board was detected. Not the entire board necessarily, but at least some of those corners were detected. Well, the corners in this case is the things that are drawn as pink dots in the image on the setup part. Are we frozen? Why are we frozen? We're not frozen. I don't know what that was. That's weird. I just had to push enter and it restarted. Anyways, it wasn't frozen, but it wasn't updating the terminal for some reason. But anyways, so camera 2 detected 1,400 boards, and now we're running through camera 3, which will have also over 1,000, which is way more than you need, but should be plenty for the calibration part. And once it's through that, it's going to start running through the rest. The outputs that come next come from AnyPose. They're helpful if you know what they are, but I think that they could, one of the things you're going to be refactoring is just making this more explicit and more explanatory. This is the numbers that are streaming through are part of an optimization algorithm, trying to find the right sort of locations and rotations of each camera that can make sense of the data that was recorded. And actually, it made it through just fine. And it's now running through the media pipe stuff, which we actually don't want to do because we're just doing calibration right now. So I'm going to hit Control C just to cancel that. And then we can look. Yeah, so these are the final sort of locations that it found for the cameras. Camera 0 is at 000. And then camera 1 is at this location. These are in millimeters. And then this is camera 2 is in this location. These are in millimeters. So X position, Y position, Z position relative to the location of camera 1. And the error at the end was the average error was 1.6 pixels of reprojection error, which is fine, pretty good. We're happy with it. And looking at the calibration the session folder here, we can look at what's in there now. So we have the raw videos of the original videos that were recorded, along with their timestamps. And synchronized videos are the ones that were synchronized. So these are all frame perfect synchronizations, so that, yeah, each of these has the exact same number of frames synchronized. And then critically, this camera calibration, calibration, because we called it calibration. The session ID has calibration at the end. This is that camera location, the camera calibration information. So you have the size of the image. This is called the camera matrix, the distortion coefficients, the rotation in Euler angles, and the translation in millimeters. And so with that, we have the calibration information we need. And so now we can think about taking the actual motion capture recording. Okay, so now that we have the calibration recorded, now we're going to record the actual motion capture data. So I have my brother over there, and we're going to do the video recording with the pre-alpha, and then once that's done, we'll load everything in, pull everything into the GUI, and then that will hopefully turn through the rest of the data to produce the sort of output Blender skeleton and all that good stuff. So we're back here. We're still in our free mocap environment, the pre-alpha one. Import free mocap. Let that go. Free mocap.run me, and we're going to say, is there anything we need to say? We actually don't need to set any parameters right now because we're just doing the video recording. So, and we're going to use the calibration from last time, and we're going to use the Blender output from the GUI. So it's going to churn through again, find the cameras. We're going to do 0, 1, and 2. We're going to go back into setup, just make sure everything's pointed in the right direction. These should all be the same parameters. Submit start, and then we'll see hopefully Paul standing there, looking pretty good. So Paul is pretty good. You can shift a little forward, that's good. And then if you stay roughly where you are, probably just keep there with the setup we have. It's not a lot of space, but that should be fine. So now that I'm happy with the setup, I'm going to push escape again just to close out of that. I'm going to give it a name. So I'm going to leave the default session ID as it is and add as a tag underscore PNM, which is initials dance mocap. And then I'm going to start recording. And then you're going to start in like a nice A pose where you're sort of standing exactly like that. And then I'll just do that for like a couple seconds, and then I'll push start on the music, and then you can dance, and then we'll sort of move from there. Okay, so begin recording. Stand there like a nice A pose. We'll be okay. And then Shabby Marak. Hooray! Okay, now I push escape. And yeah, I gotta pause. Shush. Neon X Death on SoundCloud. Brother Paul, doing great. Synchronization looks fine. It looks weird because there's this one super long frame. That's probably where I moved the camera to be on the front of the thing. That's something that can happen. But the vast majority of frames are good and on path, and we're happy, so we're going to click proceed. And then again, because we're doing this kind of janky workflow, the pre-alpha alpha sort of two-step thing, we need to get the pre-alpha to run through the stage 2 synchronization part, and then that will produce the data that we need to pull into the GUI. So basically we're waiting until this thing gets through its process, at which point this synced videos folder will have 3 good videos in it. So that process is done, and now we do have these 3 videos here for the motion capture videos, and we have the calibration data from the previous run through. So now we are going to say Conda activate free mocap dash GUI. God, what was it? Oh, then I have to cd into the folder slash free mocap, I think. Nope. There, cd into free mocap. There we go. And then Python source GUI main.py. Ha! Easy. Simple. Streamlined. And now we're going to, so we already have the videos. So these are already, we have a folder full of synchronized videos on our computer. These could be synchronized videos from a GoPro. They could be, you know, from or multiple GoPros or anything. So in this case, they're recorded from the pre-alpha. So I am going to click on this import synchronized videos button, or Control I would also work. And then I'm going to call this that underscore tutorial, and then select set of synchronized videos. And then I remember how this works. And so this is the folder, and this is the folder we just created, synchronized videos. And then it doesn't show the videos for some reason. I'll figure that out later, but they are in there, and I believe in myself. So I'll say folder. So we're selecting the folder that has the videos in it, and all those videos are synchronized with precisely the same number of frames. I mean, precisely, like exactly the same number. Click select, and then great. And then it makes a new folder. The session ID is the one that I specified, underscore tutorial, and then synchronized videos. They're all in there. And so we're basically skipping the recording step in the GUI. And now we click on the second tab here, the calibrate capture volume, and use most recent calibration. That actually probably might work, but I'm going to say load camera calibration TOML. Click on that, and then through a similar bit of flammery, go back here to where that is. And it was the second calibration was the one that actually worked. And then this is the TOML file that has the camera data for the current locations of the cameras, or rather the location of the cameras during the time we made the mocap recording. Click open, and now it knows where that is. And I think now we can go down here to record and process. We don't need to record anything because they've already been recorded. So I think we can just click process all. And oh, and it doesn't give us any information, but it does here. Oh, right. So this is using the main branch of the free mocap GUI. I'm doing a lot of work right now on the branch called John/process_data that will, in fact, improve a lot of things about the processing workflow and adding a lot more sophistication with Butterworth filters and segment lengths and all that kind of stuff. But for most people, that won't actually have much of an effect on things. It will just be better. Like the workflow will be the same, but the stuff happening under the hood will just improve the quality of the data. And a lot of quality of life stuff, for example, like proper progress bars instead of just like this sort of like print out the frame number thing. This is probably going to take a long time to process because it's the media pipe stuff takes a long time. But yeah, it's fine. So we can pause. Yeah. Yeah. So we're done with processing, except for the Blender stuff failed because I forgot to tell it where the Blender executable was. So we do that real quick, and then we'll look at the data. So this, we'll try to find the Blender executable on your computer. If Blender is in a different place than the default location, it won't be able to find it. We'll figure that out later. For me, it is here, so I'm going to select the blender.exe on Windows, click open. Now it has that. And now I think I can click export to Blender, and it will run through this Blender process to generate a .blend file automatically from the recorded data. I'm just going to make sure that it's starting, I realize it's actually going to take a second because it's kind of a longer recording. But while it is processing that, we can do a little walkthrough of the data that gets produced by a completed recording. How we doing, buddy? Doing all right? You seem like you're chugging along. Okay. Well, you just do your thing there, friend. Okay. Something's Something isn't right. What are you struggling with? I mean, it's definitely, okay, there we go. Okay. So perfect recording, obviously. So I'm not quite sure what is going on here, but I do know tab, go into edit mode, delete these bones, delete dissolve bones, delete dissolve bones. Okay, the hands got messed up, so it was made those giant bones. This is something that's also being worked on, is this sort of automated Blender output. But let's look at this. So it comes out in an arbitrary orientation. We're also working on, one of the things I'm working on in that post-processing branch is a way to sort of automatically detect gravity, which is a harder thing to do because we don't measure gravity in any way, we just measure images. But for now, you just got to grab it. If you're moving it around in Blender, grab these axes that everything is parented to and move it by that. And then we're going to move this sort of roughly where it needs to be. Grab in Y. Nope. Grab in X. There we go. And move that. Grab in Z. I wish I had my screencast keys on, but I don't. So that's life. And then let's rotate around Y. Get it roughly speaking looking okay. Okay. And we're going to turn these axes off. We're going to click up here into the material preview, and we're looking pretty okay. So this is the automatic Blender output. It is not perfect by any means, but it's not a bad place to start. It's something that we're actively working on to improve. I'm not an animator, I'm a neuroscientist, so this was me kind of trying to figure out how to sort of script Blender to make an armature that sort of resembles the kind of thing that animators and game designers can use. And we're currently sort of iterating on that process and also working with animators who are part of the free mocap community to sort of like create a better output that will sort of more easily attach to meshes and things of that nature. But that is in fact the raw data. I'm going to move this over here while I look through some of this other data. So are you playing? You are playing. Oh, but there's that whole chunk in the middle where we were trying to get the video recording. So we're going to sort of have that. But let's see. What was the name of...
Getting the music playing, you mean?
Yeah, the music playing, yeah. All right, so this session was 144444 _ tutorial, which is very inauspicious in Chinese, but we're going to pretend that we don't know that. 4 is an unlucky number in Chinese, but we're okay with that. I'm okay with that because I'm not Chinese. So this is the folder, the session folder that is there. It is also the same stuff that's here. If you want to automatically open that in the Explorer, you can, I think you just double click the folder and it will, right, yeah, there you go. So in that you have the synchronized videos, which were the ones that, in our case, we imported from outside, and it just copies them into the synchronized videos folder. Annotated videos, which is the same videos with the MediaPipe data overlaid on it. MediaPipe is just doing sort of 2D skeleton tracking from the raw images. And those are also the annotated videos are the ones that are playing in the background here. You can see them there. And the one I'm going to be looking at, also very important, is this output data folder. That is where, so if you're like a scientist or a clinician and you actually want to analyze the data that was recorded, this is where you're going to want to mostly go. And the most important ones you're going to want, so you got the sort of these big .npy, those are NumPy arrays. If you're a MATLAB person, those are equivalent to just matrices. Specifically, the most important one there is MediaPipe 3D data, and then it's a 3-dimensional matrix where the dimensions are the number of frames by the number of tracked points by the XYZ dimension. But the easier thing to work with is this MediaPipe body 3D XYZ.csv. So if you open that one up, that's just a good old-fashioned CSV, Pandas data frame friendly CSV that has the columns are, so first 3 columns are nose X, nose Y, nose Z. That's the sort of XYZ position of the nose in the reference frame of the camera. And then each frame is a row in that. So on the first frame recorded, the nose was at, you know, this XYZ location in space, and then similarly for the other data points. For media pipe, you can, so if I search for Control L, media pipe, pose, you can sort of find the media pipe documentation, and that's the naming of each key point there is happening there. And the other useful piece, and then we have the data for the face is also in there, the hand are also in there, and I guess that's it for now. I think this version on main does not yet output the center of mass, but we also output the center of mass as an MPY. That's just the position of the person's center of mass over time. And that's that. So that's the process. That's start to finish, from laptop and cameras to set things up, to point the cameras in the right direction, to calibrate the space, to record the motion capture data, to process all the who's its and the what's its, and the end result is this friendly little skeleton dancing friend and a giant pile of friendly numbers that you can use for whatever you want to use them for. Thank you for watching this whole thing. Thank you for being interested in this project. Thank you for being patient as we're working through this. It's kind of like working on the tutorial. It's just like, oh man, there's actually a lot of parts to this. There's a little bit of work involved. And trying to get it streamlined and trying to get it user-friendly is a long-term aspirational goal. It's challenging, but very rewarding. And it's been really great seeing the free people start to come to this project and sort of become a part of like the free mocap community. It's been incredibly gratifying and supportive and all that good stuff. If you're interested in following along, come join us in our Discord server. Come join us on Twitter. I stream on Twitch sometimes. I have a TikTok, I guess. And you're probably watching this on YouTube. So hang out here too. And thank you. I love you. Goodbye.